crew right now. We are in the middle of our tap water versus bottled water,
I gotta try this one again.
and we're going to see who is right. Okay, we're gonna see who's right. So you're joining us here. Hey, I am podcasting this, so this is actually beginning our lesson. So we're gonna hop right into it. We only have about 24 minutes, so I am gonna kind of go through this fairly quickly. So let's go through who's right. Okay.
Wait, did you get the water in the one that's tap water out of the fountain?
Yes. Yes,
I can
did.
tell it tasted the exact same.
Did it taste the same?
Yes.
All right, here we go. Station number one. The correct one for station number one was 1.
Yeah.
Right here.
No way.
Right here.
I didn't do station
Okay,
Oh.
both got them correct. Station number 2. The correct answer was 2. No, I'm joking. It's 1. It's 1, Maddie. It was 1.
I just smelled it.
Oh, well.
number.
2 was 1. Wes, I'm sorry. Sorry, sir.
Oh.
2 was 1. All 4 of y'all down here. Nicely done. Or 5 of you. I'm sorry, Gabby. Saw you there too. All right. Number 3. The correct answer was
3.
Three.
It's
Michael,
3. I
you
just
said-
tried the water.
It
There
was
has to
one.
be 3. I literally.
It's 3.
Yeah. I knew that.
Okay. So out of total of 14, we got 12 correct. What is the proportion of 12 over 14? Throw it in.
It's a good proportion. 0.88.
0.8.
Was that serious? Is that right?
Okay.
0.88? I can find it.
So-
Is that station
I'm kidding. I don't know if it's
It's
0.88.
This was
0.86.
station
Oh,
three.
that was my other guess.
Right here. 86?
Yeah, 0.6.
Y'all lied. Y'all lied.
That was my guess.
Okay.
I heard. I was just.
Here's the thing. This is, again, I told you, this is probably one of the most important things. And really starting to lay the foundation for Chapter 6, okay? Chapter 6 is about randomness. Now, probability is similar to randomness. It can be used with randomness. However, randomness is a whole different unit in and of itself. We'll talk about that in a second. What we're saying is 12 out of 14. Is that statistically significant to say that we could actually taste the difference between tap and bottled water?
Yes.
Another way of saying that is this statistically significant enough to say that the choices that y'all made weren't random, but they actually were based on what you actually tasted? Now, we've talked about this statistically significant, this holy grail thing, but it's been very vague. What we're going to do is define that just a little bit more for you, give you a little bit more because you're a little older, okay? And we're going to go to that here in just a second. Now, here's what I would like for us to do. 0.86 was based on what you actually did, right? But that could that happen by chance? Well, we're going to actually see that because guess what we're going to do?
Do it again.
We're going to simulate it, okay? How could we simulate this, what we just did?
Random table D.
We could do that, absolutely, table D. What is another thing we could do?
On our
Calculator.
Yeah, absolutely. We're going to actually do this on our calculators. We'll go back here, and we'll go here. We're actually going to take this down below by doing the random integer of 1, 3, 21. Now, we're not going to do 100 simulations because that would be a nightmare, okay? But what we will do is this. I want each of you to do 4 different simulations on your calculator. So you'll do this, 1, 3, 21. What will you do? How many times?
3.
4 different times, right? Okay.
You tried.
What is this saying? This is a random integer between 1 and 3, right? What is the probability that you will select a tap water, right? Well, let's do this just so that we're consistent. We're going to say number 1. If you get a number 1, that is tap water, okay? Got me? All right? So you're going to do that over the course of time. And out of 21 total times that you do that, you're going to say, how many times did I correctly identify tap water? How many times did I get 1? Got me? And you're going to come over here, and let's say I got 5 out of a total 5 in that 21. Does that make sense? Okay? And in actuality, I'm sorry, this is not 21 because we don't have 21 students in this class. We should have 14, right? So I should, let me correct that. This should be 14 because we had a total of 14 in our simulation, right? So when we come up here, out of a total of 14, how many times did you correctly identify tap water? You're going to do that 4 different times. Does that make sense? So you have 4 different dots that you'll put on here. Let's see what we get after that. Sound good?
Wait.
All right?
4 different dots.
Matt, you want me to say it one more time?
Oh.
So wait.
So we
every
put a
time
dot.
we get the number 1, we count that as getting it right.
Correct. So you're going to have a total of 14 numbers that are random from 1 to 3, right? So you can have them all out. Every time that I have 1, that counts for tap water correctly identified, okay? So this is totally random, right? What we're doing is completely random. this was this random? Could this be random? We're gonna see, right? Was it statistically significant enough to say that no, it wasn't random, right? You actually knew what you were doing. Well, we're gonna do this up here, and then I'll show you accordingly. So what I want you to do here is just tell me, oh, I only got 3 out of 14. That's okay. I'll just take a dot and put it there.
Each person puts 4
Got me,
different
do it.
dots.
Yeah.
4 different dots, so you'll have 4 different numbers. So you might have 3 on the first one, 6 on the second one, 4 on the third one. That makes sense? And so you'll have 4 different dots, and you'll just build on top of itself within our class. Got me? So we'll do this 4, and I know Mary Martha's with us now, so 4 times 15 is 60, right? So we're going to do this total of 60 here.
Wait, so
we're
do we
doing
do 15 now?
15 now or 14?
Well, let's do
14.
Let's do 14.
I've already
started.
Let's do 14. Okay. So this would be 14, but Mary Martha, you can join in. That's okay. We're just doing more simulations. That's fine. Okay. All right, rock and roll.
My calculator.
Mary Martha, are you in on the conversation with what we had earlier prior to this? Like, were you here? You came in kind of towards the end, I think, right? So basically, we tested which one, right? 1, 2, or 3 was tap water compared to bottled water. Got me? And out of the total, we got 12 out of 14 correctly identified. So we're trying to see, is that completely random, or do we actually have the ability to test or taste the difference between tap and bottled water? Got me?
One.
My calculator, like, it won't let me go over. Like, mine doesn't let me scroll past with 7.
Then go to who's right.
Yeah.
You have the same.
What do I do with these numbers?
You gotta put 4 dots, like I said.
So after you do this, and then you press enter,
It's up
you
to
go
us.
to simulation.
Thank you.
Like
Thanks,
if
Abby.
it-
Oh, I see. Okay, thanks.
Is it hot in here?
A little bit.
Ooh, a little toasty. It is 74. That would be,
I do one more.
do I dare say hot? Yes. So we'll put just 4 dots. You don't have to write them on there. Just put them up on the board there.
Don't put the long dot. The long dot. Don't put
Yeah.
the long dot.
Try to do that in about 3 or 4 minutes. We'll put it up there. While you're doing that, I'm going to throw something on the podcast just because I think it might be important here. So you keep going and then we'll talk, okay? Those that are on the podcast, this is just a heads up here. You might want to just know Section 6.1
Be a renegade.
is what we're
Be a
doing today,
trailblazer.
or into today. This introduces the random variable. That's what we're doing with this tap water versus bottled water. You see the example over here. This is an example from another class, but this is our random variable that's there, okay?
What do you have more stickers than me?
Also,
How
it
many
has
do I
what we
need?
call a
3?
probability
4?
distribution. Gives us the likelihood of a specific event happening. That's 6.1, okay? 6.2 goes into transforming and combining these random variables. What do we do when we add 2 random variables together or subtract? That's what we're looking at in 6.2. And then finally, 6.3, the big concept in 6.3 is binomial and geometric, which have their own names. Those are different types of random variables that are there, okay? So just a heads up on that. Just want to make sure we threw that on the podcast.
Because you only did 3 simulations.
Wow. Very cool.
You're supposed to have 4 dots, right?
4 dots,
Yeah.
yes.
4 simulations. But your 4th simulation.
Make sure we put 4 on top there.
What? Why are you looking at me like stupid? Everything is calculated level. Literally just hit enter one more freaking time.
You realize
All you gotta
that
do.
I'm grading your test tonight, right? You realize that. While I watch the Warriors, I'll be grading your test. Just remember that.
Well, he watches the Warriors. I prefer to watch the Cavs, but
Oh,
you know.
disgusting. Disgusting. This is true. They're not. Neither team are playing great.
All one. Oh, no, we can't score. Oh, Steph's averaging like 4 threes a game this year.
All right, does everyone have them up here?
100, 83. Four, five, so 8, 3, 5. Alright, Jeff.
Alright, we're gonna have a clean game, boys.
Oh, hold up. No, we're not dunking on people.
No, we're not dunking. Long loves getting dunked on.
I know he does. That's why
He
we're
gets
gonna.
owned in
No, hey guys, let's have a seat. We're about ready to get it going.
Knock it down.
I've got 14 minutes to describe chapter
Alright,
6.1a. 6.1a. This looks really colorful, by the way. This is Snapchat worthy.
No phones in
Also-
class.
It's also blocked.
True. No, I mean, we would never do that.
No
Right?
Snapchat in school. That's
Yeah.
blocked.
Also
Did we
blocked.
take our phones out?
What's that?
Did we take our phones out? So
Do we have permission to Snapchat
we can
that?
take our phones out?
No. Why would I ever say that? Because of Snapchat?
They blocked it on the right.
They did. They blocked it.
And it's
Wait,
and
they're blocking
everything.
everything.
I can't Snapchat during my playing period.
And all games.
Yeah, you can. Just get off the Wi-Fi
I'm
for
so
like an
neat.
hour.
Okay.
It's
The
okay.
games are blocked.
Okay.
That's blocked.
Is this? Here we go. Let's talk about this.
Fantasy football's not blocked though. They know teachers do that here. They couldn't block
They
that.
could like that or Netflix. They
Block what?
Fantasy football.
Yes, that's true. That
They
would be all.
can't do that.
Yeah.
Yeah.
All right.
Well, they can.
Hey, as we do this together, I think it's important to kind of engage with the activity. Mary Martha, would you mind hitting Wes for me? Not hitting him. There you go, Wes. Join us, sir. All right. Hey, as we talk about this, I think it's important. Okay. We're gonna take this. Okay. How do I hang this?
Yeah. With the magnet. What?
Or the sticky.
Did you see that?
There's a Post-it.
Did you see that? What's that?
Post-its.
There's not.
It's a big sticky note.
Touch it.
That's a big sticky note. I don't know if you do that or not. All right, that's how these all stick. All right. So, question: is this statistically significant?
No.
Yes.
All right. So these are all the random all the random that you have, right? These are all the random dots. Simulation.
But this isn't random. This is like skill.
Yeah,
Yeah,
this is
it's not random.
skill.
really
Yeah. So how do we know that it wasn't random? Like, what I mean by that is, how do I know that I actually went up and actually knew what the difference between tap and bottled water was? Traditionally, other than Michael and who else?
Wesley.
Wes, yeah, okay, Campbell, Wes, and Michael, you got it right, right? Michael got it right. So, when I look at this,
Sorry.
12 of 14 was correct. How can I know that it was so statistically significant that this wasn't random? Well, here we are, right? What percentage was less than 12?
Oh.
100%. In my simulation of it being random, right? How do I know it's statistically significant?
Because when you actually do it random, like it's way lower than what we got when we like said it wasn't random. Like it'd be really hard to, like when you actually do a random simulation to get 88 or 87%.
I like that. I like that more, and that's really good. Does anyone have a problem with, because when we say it's statistically significant, there's no, as I trip. I didn't mean to trip, all right? Anybody have a problem?
Oh,
Too many.
whoa.
I've been drinking too much tap water, right?
That's how we're
Too much tap water.
Impurities.
That's right.
Number
Put
one
something
is
in
tap
there. I don't
water.
know what it is. Anyway, it's totally off. Okay, so because of this, there's not really an actual number. Have you had a problem with that? When we say it's statistically significant, we just say it looks that way, or it's 100%, or like there's no actual real number that's there. So actually, there's a number with statistically significant. We're not quite there to actually solve it, but I'm going to give it to you now. If it is 0.05, got me? If it is less, or if it's more than 0.05 in terms of the number, we would say that it is statistically significant. So when we talk about that, there's kind of different levels of statistically significant, but traditionally 0.05. So let's say that the proportion of our randoms was over here 0.96. Could we say that that's statistically significant? Yes, it is, because what would be on the right side, or that's greater than or equal to 0.04, right? So we would say that, yeah, that's still statistically significant. Now, 100, we could really say that this was not, we almost are guaranteeing that this was not random, okay? Does that make sense? Okay, that's where we're headed. All right. Is it random? What does random mean? What does random mean?
Make everything
Like in this context,
It's not controlled.
Like what we did with our calculator.
Okay, it's not controlled. What'd you say?
Like what we did with our calculator.
What we do with our calculators,
Because
right?
they
I
were
like
given
it.
equal chances.
Just random in general. What does that mean?
Oh. Means everything has like one equal chance of happening to the next.
Does it have an equal chance though? Right over here, right? This was random.
No.
We had 2 bottle and we had 1 tap, right?
So it doesn't have to be equal.
There's no like bias.
Ooh, I like bias. I like bias.
Your chance of winning is not like. Yeah, it's not. Yeah, I don't know. I don't know how to phrase it. Like, I know what I'm trying to say.
It's tough to
No, I agree.
it's tough to identify, is it not? Okay. So what we're doing is that's where we're headed. Okay. So if you're like, good night, don't worry about it. You don't have to know now. Just know that this right here sets us up for where we're headed. Okay. With that being said, chapter 6.1a. All right. Here we go. Coach Jay has decided to have 3 children. Now, I don't know if that's the case. That's not fact. Okay. That's not fact. But we're just going to say that in 3 children, okay, noting that you didn't know I had a girl for the first one, okay, we're going to put that aside. We're going to say that there is a complete randomness as to whether I have a girl or boy, okay? So the sample space could be what? What's the sample space for this? Boy, boy, boy. What's the next one? Boy, boy, girl. What's the next one? Boy, girl, girl. Right? What's another one? Girl, girl, girl. What's another one?
Boy, girl, boy.
Boy, girl, boy.
Girl, boy, girl.
Girl, boy, girl. I know we're going all over. Hopefully we get them all. We got what?
Girl, boy.
Girl, girl, boy. What's the next one?
Like a tongue. Girl, boy, boy.
Boy, boy, girl, boy, boy.
Yeah, we already got that one.
We already got that one?
Oh, no, we don't. No, we don't.
Girl, boy, boy.
No, no, I correct myself.
3, 4. Do we have 8? Yes, that's it. Okay. Question. Okay. What is the probability that Coach Jay will randomly have 3 girls?
1 out of 8.
1 out of 8, right? 1 out of 8. Now I'll tell you, I thought I wanted a boy for the first child. Thought I did. I'll tell you, if I have all girls, I'm good. I love.
Oh my god.
Oh man, it's awesome.
He might be the only
For
person.
now.
He might be the only
No,
dad
for
in
now,
America
for
that
now,
feels
just
like
wait.
that.
Just
I'll
wait.
admit it. I'll admit it.
Just wait
Okay.
18 years.
So yeah, this is true.
Give it a good 13 more years.
I'm good. I'm good with that. She loves me. I love her. Okay. X is the number of girls. Okay. All right. Stay with me here. What are the possible values for X? So if X is the number of girls, what are the possible values for X?
0, 1, 2, 3.
Okay. 0, 1, 2, or 3. Is that right? So when we say the number of girls that we could have, it's possible that I could have 0 girls, 1 girl, 2 girls, or 3 girls, right? Would you agree with that? So we are going to say this is called, right, here's our probability, the probability chart that we're going to talk about, okay? All right, so this is talking about a random, when we talk about random variables, the possibilities for X values are 0, 1, 2, or 3. This represents what on top again? The amount of girls. Good, Morgan, that's exactly right. So what's the probability that I'm going to have 0 girls? 1 out of 8. Very good. Maddie, nicely done. 1 of 8. Okay, I can put a decimal. I'll just put fractions for right now. What is the probability of having 1 girl?
3 out of 8.
3 out of 8. Do you see it? Because there's 3 possibilities, right? There's possibility 1, possibility 2, and possibility, am I missing it? 3. Okay? So I would say 3 of 8. All right? Good. What is the possibility of having 2 girls?
3 out of 8.
3 out of 8, because there's 3 of them. And that leaves what for having all 3 girls? 1 of 8. Now, you see a couple things here. What does the probability all add up to?
8.
1. Was that not a question on your test? Okay. All of the probabilities have to add up to be equal to
Sure was.
1. Why is that? Someone explain to me why.
Because then it won't be complete, because then you won't have a full sample.
Okay. Someone want to kind of go off that? Because I like that where we're headed, Wes. Could someone kind of build on that? Why does it have to equal 1?
Everything has to equal 1, yeah. 1 is 100, yeah.
One
Yeah,
is-
probability is out of 1.
Yeah, so it's 100%, right? I can't break it up to 0.9, right, in terms of a percentage. If I was talking about all my sample space, that has to equal a possibility of 1, right? Very good. Okay, so is this random here? Is it random that I'm going to have, now taking all the science aside, 0, 1, 2, or 3, is that random? Yes, absolutely it is, okay? So we're going to just keep that in the back of our mind. Now, What is the probability of having exactly 2 girls? 3 out of 8. Nicely done. Good. Bless you. What is the probability of having at least, this is the key,
Oh, you got
at least 1 girl?
1 line.
7 out of 8.
How did we get 7 out of 8?
You add
Only
up 1,
one.
2, or 3.
It's not
That's
zero
0 is not
girls.
an option.
Okay, so if I say at least 1, that means 2 and 3 are also in play there too, right?
Yeah.
So we would say 3, 3, and 1 make 7 out of 8, okay? But when we talk about random variables, this is what we're referring to, and this is how we represent it, okay? That's where we're headed. Okay, now with that being said, let's keep going, okay? Go as far as we can. All right, definitions. Let's get these down. A variable that takes numerical values describes the outcome of some chance. Now, does that have to be equal chance?
No.
No, we just saw that with the girls, right? 3 of 8 and 1 of 8. Of some chance process is called a random variable, okay? So if you think about randomness, randomness is really what? It's chance. It's a chance process, okay? I love that phrase. That's a good way of remembering it. The next part, this probability table that I was talking about, it's a table that summarizes these values, what we just wrote down. We call this the official name, a probability distribution, okay? I heard that, Mary Martha. Was that you? You rock. Nicely done, okay? All right, next one is this. In the probability distribution, each probability is between what? We said it already. 0 and 1, right? And the sum of all the probabilities is equal to what? 1. Nicely done. If this is true, the distribution is called what? Normal distribution is different. Remember, we talked about normal distribution as the curve. We talk about what's up there, right? Different. We just say that if it does equal 1, we say that it is a legitimate probability distribution. Okay? So we just say it's legit. I love that word. Legit. Okay? All right? Now this is a good one here. This is a really, really important concept. A random variable that has countable numbers of outcomes with gaps. So like, for instance, with girls, I either have 0, 1, 2, or 3. Can I have 1.5? No, it's not possible. So with that being said, you have to have 0, 1, 2, or 3. So it's not continuous. Do you see that? So when we say that, we say that this is discrete. Okay? A discrete random variable. Okay? An example of a discrete random variable would be what? Just someone give me one. Number of kids. Very good, Matt. Nicely done. Did someone give me another example? Someone that hasn't gotten a ticket today. What's another discrete?
Number of water bottles.
Oh, I like that. I'll take that. Number of water bottles. Give me one more.
Number of car washes per week.
Yes, that's exactly right. Yes, okay? So we could say kids, water bottles. It got weirder and weirder, didn't we? And then car washes.
Oh, that was straight out James 1.
All right, I feel like there's something there. Okay, the next one, the second type, is a random variable that has infinite number of outcomes. Now, I'll tell you this, with no gaps. Question, what is something we've already talked about that has no gaps? Stay up here. Random variable that has no gaps. We talked about a model that has no gaps in it. What would that be? What would that be referring to? Probability. That's what we're talking about, right? That's good. What's an example of that? Here's a hint. It's right behind me. I think it is. Up on top.
The Holy Grail.
A normal distribution.
Normal distribution. That's an example of this, right? Are there any gaps in a normal distribution?
No.
No, it's continuous. You think of the curve, right? Continuous. You could be between 0 and 1, right? Okay? So within this, we call this continuous. And so if it has no gaps, should make sense. This is called continuous. Okay? Could someone describe a continuous model? It could be anything that has no gaps in it. You could say that again. Height.
Oh.
Perfect. You studied this on me?
Oh, short joke.
I knew someone was going to say it. That's why. Money? Yeah, you could do money. That's exactly right. Yeah, so we could do height, money, GPA. I could do that. Hey, have a great day. We'll hit this on Friday again. Make sure again, I'll stop the podcast. We'll go forward as well. Hey, bring your normal distribution sheet because we're going to have time to work on that come Friday. Okay? If you're not, I'll podcast it and you'll be able to check it out. Is that fair? It's not going to be a whole lot. You'll see later on.
Let me show you it again. Did you already fix it?
No, I didn't. Is that